2.6 हम लोगों ने किया है मीनाक्षी.
No, sir, I didn't do that.
No, I am saying that we have done this in class only. Okay, Khalil. हाँ, this one we have done ना मीनाक्षी, और no? याद नहीं है आपको? See, the second class. See this question. This is the same question, right?
Yes, sir.
है ना? So you just have to see this again. You will get it. Okay. And while you are writing this, and you try to understand what we have done. If you have any doubt, then just ask me. Okay, I will tell you. Like for example, if you have doubt in this portion, then just ask me later on. Okay, let's get back to 2.18. आप लोग की आवाज आज बहुत धीमी आ रही है मीनाक्षी, खास तौर से. Fine. Okay. 2.18. This question, right, Samaira? Yes or no?
Yes, sir.
Okay. So, what is the question saying? First, we have to understand that. No? What it is saying, calculate the mass of non-volatile. So it has, okay, 40 gram per mole. So it has given the molar mass as 40 gram per mole, which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. Reduces vapor pressure to 80%. Now, the most important point here, what you will use is, first of all, let us suppose, let the vapor pressure of octane be X. Okay, fine. Yes or no?
Yes.
Then vapor pressure of solution will be 0.8x. Correct? Yes or no? ये बताइए समायरा. Second point is clear?
No,
Are you
sir.
clear with this? No. Okay, fine. ऐसे लिख सकते हैं, vapor pressure of the solution will be 80% of x.
Yes, sir.
ठीक है. 80% मतलब क्या होता है? 80/100. सही है. Off मतलब into, x मतलब x. This will be equal to how much? 0.8x. अब आया समझ में?
Yes, sir.
All of you, yes or no? Please tell me. Got it? What about others? Huh?
Yes, I got it.
Got it, na? Okay, fine. Now, what is the next thing it is saying? Calculate the mass of non-volatile which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. Now you tell me what is relative lowering of vapor pressure. Now this is from RLVP. What is the formula for relative lowering of vapor pressure? Samaira, tell me. Yes, Samaira. 0. Not 0. P naught A minus P total upon P naught A will be equal to chi B. Correct? Yes or no?
Sir, are these questions from NCERT, by the way?
हाँ, ये NCERT में ही है.
Okay.
Yes, Samaira.
Yes, sir.
है ना? And also you have to use here one trick, that is P naught A minus P total upon P naught A is equal to chi B, and you will take chi B as NB upon NA. है ना? What you are assuming? Assuming NB is very smaller than NA. ठीक है? Now, what is P naught A? P naught A will be what? X minus what is P total? P total, that is P for solution, it is 0.8x upon P naught A is again X. This will be equal to NB upon Na. What will be Nb? Nb will be equal to Wb upon Mb into Na will be what? Wa upon Ma, and Ma will go above. Right. So this expression we have already seen in relative lowering of vapor pressure. Now what you have to find from here? You have to find Wb. So you'll write Wb is equal to x minus 0.8x will be equal to 0.2. And from here you can take the x common. So x will be common and x will get cancelled. So you'll get 0.2 into MB, that is 40, I think, into WA, that is 114, divided by MA, right? Divided by MA, na? MA aa raha bas. Yeah. Now what is 0.2 into, what is MB, Samaira? Molar mass of the solute is given as
40.
40 grams per mole. Very good. Into the amount of octane is given as 114 gram, na?
Yes, sir.
Okay. Divided by MA. Molar mass of octane will be, what will be the molar mass of octane? Octane is C8H18. So 114 grams. Right. So divide by 114. So this and this will get cancelled, and you will get this as 0.2 into 40. It will be equal to how much? Tell me.
Eight.
How much?
8.
Very good. That is the answer. Okay. Everyone got this? Yes or no? Please tell me. Tell you, what did we learn in the last class? Just wait a second, okay? Achha, depression and freezing point was done, na? So the next colligative property that we have to do is osmotic pressure. Before osmotic pressure, let us start with a few points. And we will understand what is osmotic pressure, and then we will write about osmotic pressure and osmosis. So let us take a container type of thing. Now, in one of the compartment, I have only water. That means I have only solvent. And in the another compartment, I have water as well as some solute. Okay. Now, compartment A and compartment B. Which compartment has higher vapor pressure? Answer me in chat, A or B. Which will have higher vapor pressure? Answer in chat, please. Mona is not here today. What happened, guys? I'm asking something now. Okay, fine. I understand now. कोई कुछ भी रिवाइज नहीं कर रहे हैं आप लोग. Which compartment will have higher vapor pressure, the pure solvent or the solution? You have here solvent, only solvent, and here you have solution. Got only two answers till now. 3. Okay, Khalid. Okay, Hishma. What about others, huh? Samaira, Minashi, Mazia. Minashi, when did you revise chemistry last time? Minashi, when did you revise chemistry last time?
For my test
When was your test?
last week.
Last week. Which chapter? Solution.
Yes.
What did you revise? Can you tell me the topic? Sorry?
Henry's law and Rolle's law.
Okay. Those were the only two. Okay. Henry's law or law. Nothing after that. Why? उसके बाद तो क्लास नहीं है ना हमारी. Minashi, yes or no?
Yes, sir.
Why didn't you revise then? थोड़ा थोड़ा ही रहता है, एक एक टॉपिक ही रहता है almost every day, right? Or at most there are 2 topics. Okay, so please at least flip some pages back. कुछ तो याद होगा आपको. It is related to vapor pressure of solvent and solution. Try to remember what type of like what should be the topic. बताइए Minashi, tell me what should be the topic. Mazia? Yes, Mazia. You can't turn the mic on. Okay. Samaira, you tell me what should be the topic. कहाँ पे देखना चाहिए आपको? This question is not from osmotic pressure, by the way. Okay. This question is not from osmotic pressure. It is something that we have already done. Now that is why most of the people they have answered till now. Samaira, बताइए कौन से टॉपिक में सवाल का जवाब होगा? Yes, Samaira. Samaira, can you please at least turn the mic on?
So maybe Henry's law.
Henry's law. Why Henry's law do you think? Henry's law में क्या होता है बताइए? We have a liquid and we have a liquid as solvent, and what is the solute? Let me also tell you now. The solute here is non-volatile. अब बताइए. You have here solvent plus solid solute. Now tell me, where should be the vapor pressure more? पढ़ाई कीजिए आप लोग, ठीक है? See, when we started colligative properties, we did relative lowering of vapor pressure, right? What is relative lowering of vapor pressure? When a non-volatile solute is dissolved in a solvent, vapor pressure of the solution becomes lower than that of pure solvent. That is the first line from RLVP, relative lowering of vapor pressure. Okay, so please guys, पढ़ाई चालू कीजिए, कुछ नहीं याद रहेगा फिर आप लोगों को. Now tell me, all of you, please turn the mic on and tell me whose vapor pressure is higher. Whose vapor pressure is higher, A or B? Whose vapor pressure is higher?
A.
Who said B? Who said B? हाँ Samaira, आपने कहा था whose vapor pressure will be higher, Samaira?
I meant A actually.
You meant A, but you said B. Very good. Why should? अच्छा, tell me why is B lower? B का vapor pressure कम क्यों है?
Because there is solid solution.
So what will happen to solid solute?
There is more attraction. Intermolecular.
Last कब revise किया था आपने? Samaira? Samaira, कब last revise किया था आपने? याद भी नहीं है Samaira को कब revise किया था आपने. Very good. Now please listen very carefully. The vapor pressure of A will be higher than that of B. Okay, A will be higher than that of B. So here we are having some vapor pressure. Here also we are having some vapor pressure, but whose is higher? A's vapor pressure is higher. So the pressure on this side is higher than the B side, is higher than the B side. First point is vapor pressure of A is greater than vapor pressure of the solution. Now, if the pressure above the solution is, if the pressure here is higher, then what is going to happen? From here, pressure is higher, and the solvent will start to move onto this side because the pressure is higher. And since the pressure is higher, what will happen? If I make a passage and in which I have put a semi-permeable membrane, SPM, semi-permeable membrane, what will happen? Due to high pressure, the solvent will flow from A to B. Solvent will flow from A to B. And as the solvent is moving from A to B, what will happen? The amount of solvent will increase here. And due to the increase in the amount of solvent, the vapor pressure of B side will also start to increase. And the solvent will keep on moving. The solvent will keep on moving until and unless the vapor pressure of A and vapor pressure of B are equal. Vapor pressure of A and vapor pressure of B are equal. Now, is this point clear? Yes or no? That the solvent will move from A to B?
Yes, sir.
Why it is moving? What is the reason for its movement? This is the reason of its movement. The vapor pressure of solvent is greater than that of solution. And until and unless there is a difference in vapor pressure, what will happen? The solvent will move. Okay. If there is no difference, that means if you have vapor pressure of A, when it becomes equal to the vapor pressure of the solution, then what will happen? The flow of the solvent will stop. The flow of the solvent will stop. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Okay, fine. Now listen. If I, rather than, what I do, I applied an external pressure. I applied an external pressure and extra pressure on B. On the B compartment, I added a extra pressure. And this pressure was so accurate that it just stopped the flow of solvent. Okay. And at this point, what I will say that, okay, fine. This pressure is what? This is the osmotic pressure. The pressure that stops the flow of solvent from a solution of lower concentration of solute towards higher concentration of solute. It is known as osmotic pressure. Here, what was happening? There was more vapor pressure here. So in order to counter this more vapor pressure, what I did, I added some extra pressure here. This extra pressure on B compartment is the osmotic pressure. Is this clear? Yes or no? Please tell me. Clear here?
Sir, what is SPM again?
Semi-permeable membrane. I will write all those things, but that is semi-permeable membrane. Is that clear? Yes or no? Tell me.
Yes, sir.
So see, whenever you have osmotic pressure, there will be two compartments. I mean, not obviously two compartments, but there will be two solutions which will be in contact with each other with some semi-permeable membrane. And one of it will be having low concentration of solute and one will be having high concentration of solute. The compartment where you have low concentration of solute, the vapor pressure will be higher at that point. And when the vapor pressure is higher, the solvent will move from low concentration to high concentration of solute. And this movement is known as osmosis. And the pressure applied on the high concentration part in order to stop the osmosis is known as osmotic pressure. Okay? Now we'll write about osmosis. And we will also write about the osmotic pressure. Please write the topic. All of you, please write the topic osmosis and osmotic pressure. Osmosis and osmotic pressure. Please write with me. The process of flow of solvent. The process of flow of solvent molecules from a solution of lower concentration of solute to a solution of higher concentration solute through a semi-permeable membrane is known as osmosis. Okay. And this is important question also with respect to CBSE examinations. Okay, in 2011, 13, and 15, this has been asked. The definition of osmosis. What is osmosis? For 1 marks only, but it has been asked. What is the definition of osmosis? What is osmosis? Okay. Now, next point, please write with me. The hydrostatic pressure which develops, hydrostatic pressure which develops on account of osmosis is called osmotic pressure. Okay. Now, this definition of osmotic pressure, it is more related to the measurement part of how the osmotic pressure is measured. But in your examination, you will write the next definition that has 3 star to it. Okay, that has 3 star to it. Please write the pressure which just stops the flow of solvent is called osmotic pressure. Please write this down. Let me know when you're done. Please tell me if you're done, guys.
Sir, wait, sir, last.
Okay.
Done, sir.
Is there anyone who's still writing? Is there anyone who's still writing? No? Okay. Now, Khalid, can I have you, please? Am I audible to you? Can you hear me, Khalid? No. Okay. Who can hear me right now? Nawal, can you hear me? Yes, Nawal. Oh, what happened? You can't turn the mic on. Nawal, can you please turn the mic on? Yes, Nawal. No. You're having Wi-Fi problems. Okay. Samara, can you turn the mic on?
Yes, sir.
Now, here I have taken 2 different solutions. Okay. two different compartments in which I have two different solutions. Okay, compartment A and compartment B. Now the compartment A, it has, so let me also, now compartment A, it has 0.1 molar NaCl, and the compartment B has 0.2 molar NaCl. Now, can you tell me the flow of solvent will be from which compartment to which compartment? Look at the definition of osmosis and tell me the flow of solvent will be from A to B or B to A.
From
Yes, Samira? From A to B.
A to
Very
B.
good, correct. A to B, है ना? From lower concentration to higher concentration. Okay. Now, let us have another case. Now, in this case, what we are having, rather than 0.2, I have 0.5 molar. Now, in this case also, Samira, the flow of solvent will be from A to B, correct?
Yes, sir.
Acha. Now you have to tell me in which of the case. This is case 1 and this is case 2. You have to tell me on which of the following cases the flow will be rapid. In case 1 flow ज़्यादा होगा या case 2 में flow ज़्यादा होगा? Where will be the flow of solvent rapid? Yes, Samira, tell me. No idea?
No, sir.
Okay. Anyone else? Hishma? What do you think, Hishma? कौन से case में flow ज़्यादा तेज होगा? Where it will be rapid? Case 1 या case 2?
Case 2.
Okay, you think case 2. Okay, fine. Khalil, what do you think?
It's a case 2.
Case 2, right? Obviously, because the difference in the concentration is higher, that means the difference in vapor pressure will also be higher, right? The difference in vapor pressure will also be higher. Now you have to tell me, you have to tell me, in order to stop the flow of solvent, I have to apply a pressure here. That, let us say this is P1. In order to stop the flow, I have to also apply a pressure here. Let us say this is P2. Okay, and this P1 and P2 are the osmotic pressure of case 1 and case 2. Is this clear? Yes or no? Please tell me. Khalil, Hishma, Masia, Samira, is this clear?
Yes.
Right? P1 and P2 are the osmotic pressure for case 1 and case 2. Now we know that P2, in the case 2, the flow is very rapid. Now you have to tell me which will be higher, P1 or P2? Which will be higher, P1 or P2? Tell me. Which is higher? Okay, Khalil, Samaira, Hishma, please answer in the chat. Which will be higher, P1 or P2? Okay. Okay, fine. Waiting for Mazia, Minashi, Nawal. आप लोग आंसर ही नहीं कर रहे हैं बिल्कुल. नहीं चलेगा ऐसे काम. Matthew, waiting for your answer also. Mazia, you haven't answered. Matthew, please answer. Matthew, did you understand what I'm asking?
No, not really, sir.
कहाँ से आप नहीं सुन रहे हैं बताइए तो. From where are you not listening? Matthew, can you please turn the mic on?
Yes, sir, yes, sir.
हाँ, बताइए. You understand in case 2 the flow will be rapid, yes or no?
Yeah, yes, sir, yes, sir. Because there is a
Then what
there's
did
a
I
difference
ask?
in concentration.
What did I ask?
Has higher osmotic pressure.
Sorry, no. First of all, speak properly. Don't mumble. Please speak properly. Matthew, tell me, what did I ask?
Which one, P1 or P2, which has higher
What is P1 and P2? First of all, tell me that. I have also told what are P1 and P2. Can you tell me what is P1 and what is P2?
The osmotic pressure in P, and P1 is osmotic pressure in that 0.2.
Case 1.
Yeah, case 1.
Case 1 and case 2.
Yeah.
Okay, fine. P1 is the pressure that is applied in order to stop the flow, right?
Yeah, yeah.
Now you tell me, which will be higher? Where do I have to apply more pressure to stop the flow? Case 1 में या case 2 में?
Case 2. Because
Okay,
there's no
Minashi.
flow.
हाँ.
Sir.
Yeah, Minashi, can I have you please?
Yes, sir.
Why did you say P1? Can you tell me? वहां तो slow है ना? You understand that the flow is slow there, right? तो फिर
Yes.
उसमें ज्यादा प्रेशर क्यों लगाना पड़ेगा आपको रोकने के लिए? Yes, Minashi.
Yes, sir.
Where is the flow slow? Slow कहाँ पे है flow? The flow of solvent is slow in case 1 या case 2?
Case 1.
Case 1 it is slow. So we have to put more pressure to stop that flow या less pressure to stop that flow?
Less pressure.
Okay. देखिए यही फायदा होता है जब आप see I did not say anything different, right, Minashi?
Yes.
Now, but your answer has changed now, correct?
Yeah.
The only difference is that now I am talking to you. Earlier आप जवाब नहीं दे रहे थे, correct?
Yes, sir.
Now this is the benefit of talking. When I ask something, I expect that most of you please turn the mic on and answer with this is the case and this is the case. हमको एक बच्चे को पकड़ना पड़ता है because no one else will listen them. Okay. So when I ask some question, please try to answer it. Okay. All of you, those who are listening, please just try to turn the mic on and answer. Nawal, आपको समझ में आया? Yes or no? Please tell me. Yes, Nawal. Okay. Now, now please listen very carefully. Since we have seen that P2 is higher, one thing that I also saw was the concentration is also higher. And the P2 is higher and the concentration is also higher. That means I can say that osmotic pressure, it is directly proportional to the concentration. It is directly proportional to the concentration. Is this clear? Yes or no? Please tell me. Is this clear? Yes or no? Please tell me, guys.
Yes.
Right. And now you will write pi. That is osmotic pressure. Okay. Osmotic pressure is given by this letter pi. It is directly proportional to concentration. And the concentration term that is directly proportional to pi is what it is? Molarity. If you remember molarity is what it is? Number of moles of solute divided by the volume. Now, in order to, when we remove this proportionality sign, I'll get a equality sign here, NB upon V, and the and the constant, it comes to be R into T. Now, if you see this, it is very similar to the equation of ideal gas, that is PV is equal to nRT. PV it is equal to nRT, right? Here also you can see pi is what? Osmotic pressure into volume will be equal to nRT. So you can directly remember this as PV is equal to nRT, where P is the osmotic pressure, or you can remember it as pi is equal to CRT, where C is the concentration. C is the concentration in molarity, in moles per liter. Clear as सबको? Yes or no? Still, you please write this down. Let me
Yes.
know when you're done. Write this down fast. Let me know when you're done. Done, all of you? Is there anyone who is still writing?
Yes, sir.
Okay. Pi is osmotic pressure, okay?
Done, sir.
Done. Is there anyone who's still writing? No, na? Okay, fine. Now write topic. Determination of molar mass of solute using osmotic pressure. Molar mass of solute using osmotic pressure. ठीक है? चलिए, please write with me. Pi is equal to what? NB upon V into RT. NB will be equal to how much? WB upon MB into V into RT. Now we can write MB is equal to, MB will be equal to, this is pi here, WB into RT divided by pi, that is the osmotic pressure, into the volume. Now see these formula or these equations that we have for MB and all that, see these are not very much important in terms of numerical problems. Please remember this. These are important, and why each and every teacher writes these things is because in NCERT or in CBC examination, you can directly get a question. How can you determine the molar mass of the solute using osmotic pressure? In that case, you just have to write these lines. Okay, that is the importance of this topic. Please don't waste your time remembering. Okay, if you can remember easily things, then you should remember this formula also. But the main formula for osmotic pressure is this one. Okay, and it's not my habit to mark each and everything as important. Okay, so this is the most important formula for osmotic pressure. Like remember less things, but use your logical mind as much as you can. If you can remember this pi is equal to CRT, आप कभी confused भी नहीं होइएगा, right? But if you remember this, you will be always getting confused. कहाँ पे WB है, कहाँ पे WA है ना? So please try to remember the most original or the most fundamental formula, and after that you can easily derive. चलिए, let me know when you're done. After that, write a note. You can write a note. Let me just scroll this up. I write a note here. Osmotic pressure is used to determine the molar mass of macromolecules like polymers and proteins. Due to ease of measurement and significant accuracy. Okay, so this question was asked in 2015. Which colligative property is used to determine the molar mass of
Sir, in the
macromolecules?
textbook there are like 3 or 4 points related to this, right?
Related to what?
This osmotic pressure using osmotic pressure to determine the molar mass.
Using osmotic pressure to determine the molar mass. Yeah.
Yeah. Okay. So is this like a short form of that, or?
Yeah, correct.
Okay.
So can you repeat the question which you told?
The question was asked that which colligative property is used to determine the molar mass of macromolecules? If you want to write elaborative points, na, then see the ease of measurement. It includes the point of this can be measured at room temperature only. And you don't need anything else. For example, if you want, like if you are using boiling point, then you have to boil it, right? And when you are boiling something, what can happen? The macromolecules, it can get get dissociated, or it can break into parts, right? And for example, in freezing points, sometimes what will happen? The solubility will be so low for one macromolecules that when you start to freeze it, they will come out of the solution and they are not anymore dissolved in the solution. That is why this is used. So the ease of measurement is the big point, and the slight significant accuracy, it includes the point that the value, if you remember this elevation boiling point, the difference was very little. For example, 0.49 degrees Celsius, 0.15 degrees Celsius was the difference in the temperatures of boiling point of solvent and solution. But here in osmotic pressure, the values is large, and that is why you can easily measure those values and you can get significant accuracy. Okay. Also, one more thing is that you should also know the colligative property is inversely proportional to the molar mass, right? And when it is inversely proportional to molar mass, that means if you have macromolecules, the colligative properties, its value will be even lower. And so, for example, proteins, they are very large. They have like thousands of carbon atoms, and if you have thousands of carbon atoms, then you can assume how many other type of atoms will also be there with hydrogen, oxygen, and nitrogen. Okay, that is why this is very helpful. Osmotic pressure is helpful. Done all of you? Yes or no? Please tell me. Is this done?
Yes.
Okay. Yeah, write a question. Achha, before that, write a point. Necessary condition for determination of MB. MB means molar mass, okay, of solute. I'm writing the point, okay? You just note it down. I'm muting myself. Done everyone, yes or no? Done guys? Okay. You can write a question, okay, with me. Please write a question. A solution was prepared. Solution prepared by 8.95 milligram of a gene fragment in 35 ml of water. In 35 ml of water has an osmotic pressure of 0.335 torr and 25 degree Celsius. Right, assuming the gene fragment is non-electrolyte, determine its molar mass. Okay. Now this is pretty straightforward question. But first of all, you have to convert each and everything because you have milligram, milliliter, torr, and degree Celsius. You have to convert these units. So we'll start with WB. That means the mass of solute is given as how much? Tell me. Minashi, tell me what is the mass of solute?
So 8.85.
8.95. Huh?
9.9.
8.95 milligrams. So this will be equal to 8.95 into 10 to the power minus 3 grams. Next is ml, volume. Volume is given as 35 ml, which will be equal to 35 into 10 to the power minus 3 liters. Then what do we have? We have, let's write temperature first. Temperature is 25 degrees Celsius. Converting this to Kelvin scale, it will be 273.15 plus 25. This will be equal to 298.15 Kelvin. Next, what do we have? We have pi. Pi is equal to 0.335 torr. Now, who will tell me what is how to convert this to ATM? What should I do? Okay, to convert this to ATM, you have to divide this by 760. After this, you may write it like this. As pi is equal to CRT, which is equal to NB upon VRT. Pi is equal to WB upon MB into VRT. And MB is equal to WBRT upon pi into V. Now, WB is equal to 8.95 into 10 to the power minus 3 grams multiplied by R. What should be the value of R? Tell me. We have volume in liters and pressure as ATM. What should be the value of R?
8.831.
Arey bhai, kyun? That is for joule per Kelvin per mole. Now, this is if you have liter ATM, it will be 0.0821. Okay. 0.0821 liter ATM per Kelvin per mole. Now you will multiply this by temperature. What is the temperature? Temperature is 298.15. Now you have to divide this by, I will multiply 760 because it is 0.335. Further multiplied by the volume, it is equal to how much? 35 into 10 to the power minus 3. So यहाँ पे आपके पास ATM है और यहाँ पे आपके पास liter है, right? Now there are things that you can cancel from here. ATM and ATM will cancel. This Kelvin and Kelvin of this will cancel. And what do we have else? Liter and liter will get cancelled. Grams and per mole will be remaining. So we are fine. We are getting the unit as grams per mole. That is the unit of molar mass. Also 10 to the power minus 3, 10 to the power minus 3 can be cancelled. Now what is remaining? 8.95 into 0.0821 multiplied by 298.15 divided by 0.335 into 35. Okay. Now for solving this, now don't just start solving it with decimal points. Okay. Kabhi bhi. Never solve with decimal points. Okay. Never solve with the decimal points. How will you solve this? You will solve it as 895 into 10 to the power minus 2 into 821 into 10 to the power minus 4. 1, 2, 3, 4. Na? Yeah. Into. You can keep it as 298. I don't think it will make much difference if you keep it 298. Divided by 0.335. You will this will be 335. 335 into 10 to the power minus 3 into 35. अच्छा ये सारी चीजें सबको समझ में आई कि नहीं आई? Yes or no? Please
Sir,
tell
you
me.
missed
Yes.
760.
क्या? Sorry.
You missed 760
I missed
into
760. No? Yeah. Sorry. 760 will be there. Okay. Now from here, as you can see, 10 to the power minus 3 is here, and 4 and 6, 10 to the power minus 3 will be above only. So 895 into 821 into 298 into 760 divided by 335 into 35 multiplied by 10 to the power minus 3 हो जाएगा ऊपर है ना. 4 plus 2 is 6, minus 3 will go above, it will be plus 3, and minus 6 plus 3 will be minus 3 grams per mole. Now simplify this one. Khalid, do you consider this 10 to the power minus 3.
Yes, sir.
नहीं, इतना नहीं आएगा फिर आपका. It will be like 8 zeros. 4, 5, 6, 7, 8 divided by 2, 3, 2. नहीं, इतना नहीं आएगा. Anyone else has got the answer? Minashi, that is correct. Khalid, please look into your 10 to the power. That is not right. है ना, 2 more minutes. जल्दी सॉल्व कीजिए आप लोग. You can make some approximations, okay? Please make some approximations. You can see these are very large numbers. Little approximation will do no harm. Those who have calculated for once and they are not getting the answer, see, as a not in the main paper, but like in the rough part of your paper. Now, what you can do, you can solve for this 900 into 800 into 300 into 760. Okay, divided by 335 into 35. इसको solve कीजिए. You will get similar type of answer. You have to divide it also, na bhai. Salman. There is 10 to the power minus 3 also then.
Okay.
Fourteen is right. आप लोग को आंसर वो तो सही आ रहा है. It is approximately, see, accurately it is 14193. Okay, grams per mole. If you will solve this will come approximately equal to 1400. Salman, fine, correct. So not 1400, 14,000. ठीक है. Okay, so all of you copied this, right? Yes or no?
Yes, sir.
Okay. Now write the topic, biological importance of osmosis and osmotic pressure. Okay. Now, the biological importance is that, see, the most important part is you must have seen that people, they get saline water, right? They get drip when people are ill, right? Yes or no? Saline water, pani chढ़ते हुए देखा होगा आप लोगों ने, yes or no?
Yes, sir.
Right. Now, when we are giving saline, when anyone is getting saline, so that saline water, it should have osmotic pressure, and this osmotic pressure should be equal to the blood cell. Why? Because if there is a difference in the osmotic pressure, what will happen? If there is a difference in the osmotic pressure, then what is going to happen? The solvent will flow from lower concentration of a solute to higher concentration of solute, right? And when the solvent will flow, that means if you are having water, then water will flow to the blood cell, and what it will do, it will lead to swelling in the blood cell, right? And if, let us say that the osmotic pressure is less, then what is going to happen? The water will flow away from the blood cell, and what it will do, it will shrink the size of blood cell. So both of these things are not good. Both of these things are not good. Okay. Now I will write a question, and this will also be under the topic of biological importance of osmosis or osmotic pressure. Write the question. What will happen? If saline water has concentration, number 1, less than 0.91 percentage mass by volume. Okay, so this 0.91 percentage, if you have NaCl solution of 0.91 percentage, then that NaCl solution, it has the same osmotic pressure as that of blood cell. Okay, now if it is less than 0.91 percentage, then what is going to happen? If it is less than 0.91%, it means what is going to happen? Tell me. The osmotic pressure will be less or more. You all know that osmotic pressure is directly proportional to the concentration, right? If the concentration is less than 0.91, that means the osmotic pressure will also be less than that of blood cell. So we will write here the osmotic pressure of saline water will be less than that of blood cell, है ना? That of blood cell. And what is going to happen? And water will flow inside the blood cell causing it to shrink. Is that right? Yes or no? Please tell me. Oh, sorry. Shrink nahi hoga. If it is flowing inside, I should have written swell, not shrink. Second point, more than 0.91 percentage M by V. Now the osmotic pressure of saline water will be more than that of blood cell and water will flow out of the blood cell, causing it to shrink. Done, guys? Yes or no? Please tell me. All of you wrote these 2 points.
Yes, sir.
Hania, you're quite late, huh? When did you join the class? Hania? Hania, can't turn the mic on. Acha. Also, right? See, you have saline water or any type of solution. Okay, any type of solution is there. If its osmotic pressure is more than blood cell, then it is known as hypertonic. Hypertonic solution. If you have solution whose osmotic pressure is less than blood cell, then it is known as hypotonic. And if it is equal to the, what happened, Hania? If it is same as blood cell, then it is going to be isotonic solution. Right? See, hypertonic solution, if you add it, if you inject it intravenously, that means if you inject it in the veins, then it is going to, it's hypertonic, that means osmotic pressure is more, the concentration will be more, right? So what will happen? The blood will come out here, it will come into the cell. Tell me, guys. If it is hypertonic, what will happen? The cell will shrink as well.
It will shrink.
Shrink, right? Blood cell will shrink. If it is hypotonic, blood cell will swell. And if it is isotonic, it is normal. Nothing is going to happen. Also write a point. People using a lot of salt in food. People using a lot of salt in food experience water retention leading to puffiness. ना फूला फूला सा बदन हो जाता है उनका. And this is known as edema, called as edema. Then all of you, yes or no, please tell me.
Done.
Everyone done? Right, the next topic. Reverse osmosis. So this topic is quite simple. We have two compartments and there is a passage, and this passage has semi-permeable membrane. Let's say we have here we have solvent, and here we have solvent plus
Wait, the highlighted one, it's edema, right?
EDEMA ना, सही
Okay.
लिखा है ना हमने? हाँ, I think it is EDEMA. Solvent plus solid solute. Okay. Now A and B. So all of you know where will the pressure high? In A the pressure will be high, right? In A the pressure will be high, and that is why the solvent will flow from A to B. The solvent will flow from A to B. But what if we apply internal pressure so high on B? What I'm doing, I'm applying a external pressure that this P external is higher than the vapor pressure of A. The total pressure that I have applied in here, it is higher than that of A. Then what will happen? Solvent will flow from B to A. Solvent means if I have water here, then only and only water is going to flow from B to A. Only and only water is going to flow from B to A, and that is why here what you will have, here you will have some kind of outlet, and from which you can get a safe drinking water through reverse osmosis. And osmosis is where the solvent is flowing from lower concentration to higher concentration, but by the virtue of the external pressure, what we have done, we have reversed the flow of solvent from a higher concentration to lower concentration, and that is reverse osmosis. Is that clear, yes or no?
Yes, sir.
Right. See, it is very it's pretty simple concept here. The vapor pressure was high in A than in B. That is why we were having osmosis. But if I apply external pressure so much so that that pressure is greater than that of the vapor pressure of A, then the osmosis will be reversed, and that is why it is reverse osmosis. Okay, it is reverse osmosis. Chaliye. Now we can also write what is reverse osmosis. The process of movement of solvent through SPM. What is SPM? What is SPM?
Semi-permeable.
Semi-permeable membrane.
Semi-permeable. Thank you very much. From a solution of higher concentration, है ना? Higher concentration वाला क्या होगा? आपका impure होगा. To lower concentration. Lower concentration वाला आपका pure होगा, right? To lower concentration. The process of movement of solvent through semi-permeable membrane from solution of higher concentration to lower concentration by applying external pressure on the impure side is called reverse osmosis. Clear है सबको?
Sir, can you explain this one more time? Because I was not here.
हाँ, no problem, no problem. अब ये बताइए सलमान, A और B में कहाँ पे प्रेशर ज्यादा होगा? We have in A that is pure solvent, and in B we have some solute also. Where will be the pressure high?
Vapor pressure will be high in B.
अरे आप मार खा जाइएगा. सही क्यों नहीं बोल रहे हैं आप? हैं बताइए तो सलमान. Why B?
Like B is solvent, right? Like mixed solution.
हाँ, B is solution ना. नहीं, कब रिवाइज किया था लास्ट आपने?
Oh, sorry,
बताइए तो
sorry.
सलमान.
My bad. I mixed it up. Okay, A has, yeah. My bad. I mixed it up. Sorry.
Okay.
I revised last week only for a test.
अच्छा. Okay, fine. So we have it's pretty clear ना. A will have higher vapor pressure, correct?
Yeah. Okay.
है ना? A will have higher vapor pressure. So evidently the flow of solvent will be from A to B, because where the pressure is higher, solvent will move from A to B, correct?
Yeah.
Okay. Now, what if we apply an external pressure on B side, like very high magnitude of pressure, and so much so that it is also greater than the vapor pressure of A? Okay. Now we have applied a P external that is even greater than the vapor pressure of A. Now what will happen? The flow will be reversed, right?
Yeah.
यहाँ पे हमने दबा दिया. That is what reverse osmosis is. You have impurity here, right? In this part you have impurities, and you need only what? Pure water. So you apply external pressure here, and what is going to happen? The only water will flow from B to A, and you will get a pure solvent, that is pure water. Clear? Yes or no?
Yes.
Clear? Okay. Now, for all of you, there is one announcement about a Viva on Thursday. There will be a Viva on Thursday, and you will be asked till depression in freezing point. Okay, till, not only till depression in freezing point. Is that clear? Yes or no? Please tell me.
Okay, sir.
This is ask questions, right? Like
Sorry.
you'll ask the questions, right? Not writing.
I will ask.
Yeah,
the
okay.
Viva I will ask the questions.